Okay, so welcome everyone to this Science Cafe on a very different topic. We have the pleasure and honor of having here Professor Reinhard Werner from Leibniz University Hannover. And Professor Werner is really one of the main figures in quantum physics. His works are really milestones in quantum information theory and foundations of quantum physics. But he is not going to talk about quantum physics. Instead, he will discuss with us about a very important topical problem, that is there any way of actually assessing or evaluating scientific work and scientific publications, but more than scientific publications, I think. And I'm very, very happy to introduce Professor Werner.
First of all, thank you, Sabrina, for this very kind introduction. So my topic is, can we measure the quality of scientific work? Right? And so the first question could be then, why would anybody want to do that? And actually, there are many people out there who are interested. So for example, a selection committee for a professorship or a grant agency would like to base their decisions on who are the best people, right? And what is the best work, and therefore what should be funded. Or university administrators in general have a strong interest in doing that. So there is actually some demand for ways to assessing the quality of scientific work. And there are also many offers of this. So there's they call this bibliometry. So you look at the articles, you count citations. I'll explain this in more detail later. So there are ways to look at, to formally process papers and then try to find out which are the best by just numerical criteria. And there's a whole industry around that. And sorry. So one of the arguments one hears very often in this context is that it's good to have something like that. That is criteria that you can just compute from the citation statistic of a paper, because that is supposedly objective. Right? So if something can't be measured, it isn't real for some people. And scientific quality would be, if that were measurable, that would be give us a way to make judgments about papers that avoid certain obvious biases. For example, in a selection committee for a professorship, you want to avoid the situation that people are just hiring their friends and disciples. Right? So, but if everybody is measured along the same criteria, that wouldn't happen so easily. Or I've frequently heard the argument that in some departments, the people who have been there for a long time, like the old professors, are powerful, but this is not really borne out by what they actually can do academically. Right? So it's just locally, the local chief may in the end be not such a good scientist as the young guy who has sort of a conflict with the old chief. Right? So, and in this situation, there could be a benefit from having a criteria that are the same for everybody, right? And in that sense, also objective. Okay, so let me. I mentioned this already. How these metrics, these ways to measure scientific quality, supposedly, how they actually work. So I don't know how many of you have a scientific background. Could I ask such a question, like who's working in science? Quite a few. Okay, but anyway, so this is very simple actually. So all the results of scientific work are published in papers in journals, and then whenever you use something that somebody else did, you're supposed to put a little footnote pointing to the other work, right? So typically academic papers in such journals have a long list of references at the end, which are just the list of other papers that are being referred to. Right? This is actually quite different in different disciplines. I'll come back to that. I mean, the number of citations is very different. So for example, mathematicians might cite just 3 papers, and they cite only the stuff that they actually used from other papers. Physicists cite about 10 times as much, and biologists even more. Right? So there's some differences in the citation culture, but these numbers these numbers are just available, and they can be used for just counted. Right? So what happens is that there are companies that take all these papers, and then they look how often a particular paper was cited. So these are the most frequent raw data for these bibliometrics. So just citation counts. Right? So if a paper is cited very often, supposedly it's an especially good paper. So so this was started actually. So looking at these citations in this formal way was started with a project that was called the Science Citation Index. These were big volumes that every university library would have them, big volumes in which all these citation data were collected, but collected under the heading of the paper that was being cited. So, for example, suppose I solved a famous open problem. Right? So I will definitely have to cite the paper in which this problem was stated. But I also know that everybody else who might have something to say about this famous open problem will also cite that paper. So if I then take the Science Citation Index, I can look up this paper where the problem was first stated, and then in every yearly volume, I can find whoever cited that. And then I have to look at all those papers, and I can see whether something relevant was said. So this was a very important search tool, the only one that allowed a forward search in time, right? So to see what became of a topic, right? And of course, these printed volumes no longer exist. It's all done online and in databases. But so before the computer age, this was really a very important tool for the scientist, right? Just to find out what else had been done about a topic. Science Citation Index. Started by a guy named Eugene Garfield. And then came the time when searching for scientific purposes was mostly done on the net. Well, partly such data, but also just a full text search using Google or whatever, search engines. So using a search engine that covers the whole net, of course, gives you many more hits than this very restricted kind of searching. So actually the company who owned all these data now was looking for a new use for them. And this new use for these data, in some sense, was assessing quality. Right? So making it a judgment tool. So it became, it turned from a tool for the scientist into a tool for the administrator or something like that. We still use the citation index or something like that. I mean, it's modern successors for this kind of search, but the importance of that tool has gone down very much, whereas the main use of these citation data now are judging people, well, papers, people, and journals. Okay, so this is roughly how it works. Now the main players here, so this company I was talking about, what's called the Institute for Scientific Information, it is now owned by Thomson Reuters, big company, publishing house, and other things. There is a product by Elsevier called Scopus. You can also track citations with a branch of Google called Google Scholar. This has the advantage that it also finds hits that are just web sources, right? Whereas the Science Citation Index and Thomson Reuters, they only look at English language journals, scientific journals, and there is a somewhat restricted list that they look at. And there are other projects of also using different data, something called altmetrics, where they try to sort of capture the noise from the social media. So if a paper is tweeted very often, then this gets points on altmetrics. But the main thing to look at here would be just citation data, the way I described it. So my next question is that a measure of quality? Right? So let's say if a paper was cited, well, actually, one thing I should say is that the numbers of citations is often depressingly low. Right? Some papers get never cited. Many papers have like a handful of citations, and this is very varied, right? And I'll explain why. Right? So, for example, my most cited paper has something like 3,000 citations. That is considered fairly good, right? But not it's by far not the top, right? So there are some papers I cited much more than that. So the distribution is very uneven. Okay, so is it a measure of quality? Well, scientists are in a very good position to answer this question, because we are the people who do the citing, right? So we know exactly why we do that. So, for example, when I use a concept that was introduced, that is named after a person, then it's good practice to make this little square bracket and a footnote and point to that paper, if only to explain the terminology. Why do I call this the Schmidt decomposition? Then I point to a particular paper where someone can find that and understand why I give it that name. Right? So that's one reason to cite. Of course, if I directly use a result by somebody else, I have to cite that. But there are many reasons actually. But you might want to give a helpful hint where I can learn more about something. Right? So you're using a concept that is maybe not so current in the community you're writing for. So it's good practice to give a hint to a textbook or some other source where one can learn about such things. Right? And there are less honorable reasons to cite. For example, these papers, and you send them to a journal, and then they're sent on to a referee, right? To a person whose name you're not told, who will help the editor to accept in the decision whether to accept or reject the paper, or maybe revise it. Right? So this anonymous referee, in small communities, there are some people who are likely to be asked as referees because they are supposed to be experts on what you are writing about. So some people will make sure that they cite all the big shot referees. Or then also you could cite just to appear to have read a lot, right? You can cite because it's nice to cite your friends, because that will improve their citation statistics. And then many more things. Also, for example, you should definitely cite a paper that you are criticizing. It doesn't just mean that you find this is a good paper. It just means that you refer to it. Right? So there's a mixed bag of reasons. And the only thing that is usually not part of the reason to cite is praising a paper. Actually, so this whole idea that the citation count is a measure of quality is based on this idea that by citing we are sort of having a vote which is the best paper. And that's definitely not true. Right? Most of the reasons to cite a paper are quite different from that. Right? So this is the source side. Right? If you ask the people who do the citing and why they cite, it's hard to support this idea that many citations automatically mean quality. So the next thing you can look at is make a sample where you can judge quality and then compare with the citation counts. So if you're halfway experienced scientists and you've written a a bunch of papers, then take your own papers. That's my advice. Take your own papers. Make a list of which of those are best. Usually people know pretty well which are their best papers, right? And then compare with the citation statistics. And my prediction is that you will find that these lists don't match very well, right? There may be some matches, right? Of course, there is a brilliant, famous paper does get cited more. There's a correlation with quality, but it's not directly a measure of quality, and you'll very quickly find that out when you look at your own citation statistics. So then also, these citation databases tell you who cited your papers. So you can find what papers are being cited for. So for example, let me just take my most cited paper. Actually, the second cited is just about to surpass it. I learned that in the preparation for this talk. I don't usually look at these statistics. So, but I did check why people are citing that paper. So in that paper from 1989 in the Physical Review, I solved a problem that actually, when I wrote the paper, I thought nobody would ever read it because that topic wasn't fashionable at the time at all. This was entanglement theory. Right? I introduced a notion that is now the current notion for mixed states. At least people cite that paper for it. I did that much earlier, but it doesn't matter. So there's a new notion there. There's, I could say, a fairly deep result. And there's also a kind of states that are used in the construction, so quantum states used in the construction, that a guy some years later was kind enough to call Werner states. So they are named after me. Right? So you can guess, why is this paper cited so often? Because of the deep result? Because of the new notion? Well, some citations, yes, but by far the most go on the Werner states. Right? So this means that, and this is as I said, this is good practice, right? So so when I cite some notion that everybody knows by a person's name, then I point to the paper that makes this connection. This is good practice, but that doesn't mean that this is the reason why this is a good paper. Right? So the reasons for citing are not praise or a measure of quality. Okay, so this is the second sort of test that you can make on that underlying assumption that citation counts are a measure of quality. There is sort of an official version of this. There was a paper in Nature that was in, I think, 2000 and it doesn't matter. Yeah, October 2014. So in that volume of the journal Nature, there is a paper describing the best 100 papers ever. The authors are actually employees of the Thomson Reuters company who does the citation counts, so you can bet that their notion of scientific quality is citation counts. Right? So that's their product. So, when they did that, so they take the all-time citation data and find the most cited papers. Right? A very easy exercise. But they also, before doing that, they made a list themselves of the papers they were sure to find there in the top 100 or the top 10 maybe. For example, the Watson-Crick paper on the double helix. That is something that surely should be there. Or maybe Einstein's relativity, stuff like that. Right? And again, no match at all. So you would find these papers fairly highly cited. They would be somewhere in the top 1,000 or so, but they were not in the top bracket. And again, you immediately understand what happens when you look at the top 10 papers or so. I think the top 10, maybe with one or two exceptions at most, are all papers that establish some procedure in the life science, some laboratory procedure in the life sciences. Right? So you have the so-and-so method for determining I don't know what. Right? And again, you have this named thing, and it's good practice to use that name, but this happens all the time in every lab, everywhere, right? So this gives very, very many citations. And these are easily these definitely make most of the top 10 and even further down, right? So something that is found useful by many people, of course, gets cited, especially when it's a named concept, where this is almost forced. But these are not the breakthroughs of science. This door and I are fighting. No, it's good. Okay, so the real breakthrough papers will not be there. So if a department wants to hire and they go for high citations, they might be hiring a guy that did something that was helpful for the routine of many others, but not necessarily a creative genius, right? So so apart from judging papers, individual papers, you have this bibliometry is applied also to people. So I can take my own, for example, in a hiring committee, clearly you want to find the best scientists. And then you can look at the citation statistics of all the papers of this person. But what people like even more is making a single number out of it. And there is a single number that is popular for that purpose. It's called the H index, named after a guy named Hirsch, a solid-state physicist, who came up with this idea. Now, there were two maybe relatively stupid ways to doing this counting. One is you just count the number of papers, but then you could be counting many papers and nobody ever read. That was basically sterile, right? Or you could count the total number of citations, but then it could happen that somebody has one very highly cited paper, but has written very little, right? So to make a compromise between these two, Hirsch proposes to make a histogram of the papers, so the number of the paper, and you order the papers by the number of citations, right? And then the other axis is citations. So if you have one very highly cited paper, then less cited, and so on. And so this gives a curve that always looks like that, right? It has to be monotonely decreasing by construction, right? And then you write, in this diagram, you make a line at 45 degrees. And where it hits this curve, you call this point you call the H index. Why 45 degrees? I have no idea, right? So you could take any other angle. But this is we could call it the Hirsch constant, right? So there's nothing special about 45 degrees. Obviously, you could take anything. So in other words, your H index is 42 if you have at least 42 papers, each of which is cited at least 42 times, right? So this is the definition of the H index. Now, I mentioned earlier that the citation habits in different branches of science are vastly different, right? And so if you compare a mathematician and a physicist in terms of H index, the physicist will always win, no matter what the actual quality of these people, right? So this citation counting has been going on for quite a while. And I have one paper together with, a few papers together with a mathematician from Iowa, Palle Jørgensen, that did very nice things, very good mathematician. And he had to compile these data and said, you know what, our papers are still by far highly cited ones. Very simple explanation, those were in physics journals. So I'm not saying these were bad papers, but I know the output of this man, and they're not his best papers, right? He did other things that are much more profound, right? Okay, but that's the way it goes between different disciplines. So partly the H index just measures the discipline you're in. I was in a selection committee for a job at the German metrology lab just last year, and I came across so H indices, the typical H indices of So, they increase with age, right? By definition, they increase with age. Because citations don't go away, right? You can only be cited more in the course of time. So it partly measures age, right? And so my H index, which is around 46 or so, is, well, sort of is okay for that stage of career. But then we had one applicant with an H index of more than 200 or so. And so what happens? Very simple. Can you solve the riddle? How do you get an H index of 200? Well, you just have to be a high energy physicist. Because they put as an author list of a paper, for example, when they discovered the Higgs, right? Then the author list was longer than the paper. So everybody who contributes to such a massive enterprise is actually put on the author list. Not doing that would be kind of unfair, actually, because it is an industry-like effort, right? So, and not counting that at all would not be fair either, right? So anyway, that's the way they do that. But that means that many people appear on many papers that are also highly cited. and therefore, the H index of these people doesn't say anything because they're just always very high. Actually, this applicant had actually written, and here are the papers I actually contributed to. So there were like 10 papers or so, right? So, there is an extreme effect from community, and you might say, well, then if you hire a physicist, then you know what the expected H index of a physicist is. But the same thing happens in subdisciplines. So it's never fair, right? You're always partly measuring the community and the citation behavior of a community. So another thing that is also measured, as it goes into this kind of measure, is the presence of non-Ascii characters in your name. Simply because databases, the raw data of these databases are often very, very bad. They're not done very carefully, right? And that can easily happen that if you have a Russian name or some that exists in several transliterations, or if you have an umlaut if you're German, or stuff like that, then your name will appear in different versions in the databases. So many of the citations that actually go to your work will not be found by these automatic processes, right? So if that's not done very carefully, and it isn't, I can tell you it isn't, then this is a huge handicap, right? So actually many of my German colleagues dropped the umlauts very early in their career, right? Okay, not such a big loss maybe, but another version of this is there's in my field, quantum information theory, there is a family that published together in Poland, the Horodecki family. Now, if you speak Polish, you will cite R, P, and M, Horodecki. I don't know how to pronounce that, but the name is actually changed in the plural. It's spelled with CCY, if there are many Horodeckis that you're referring to. All these citations are lost to the Horodecki family because no database knows about this. So I was talking to one of them who had to compile these statistics for his habilitation, and he had been hunting down such citations to get his habilitation done. So ridiculous stuff like this happens all the time. So this is judging persons. Judging journals is another thing, right? And this is actually, this is called the H index is for people, and what's called the impact factor is for journals. Now, the impact factor is basically the same thing. You count how often papers in that journal were cited in some interval, typically 5 years, I think. And so again, typical impact factors are not very high for most journals, but there are some journals that have very high impact factors. And this was actually started by the people who started the Science Citation Index. Eugene Garfield has a nice article where he describes what they're doing. Remember these, how the Science Citation Index was compiled. You have to go through all the papers, and this was in pre-electronic times, right? You have to go through to the library, go through all the papers in a journal, and write out the citations. Now this was a lot of work and was costly. So they decided to only take those journals that give you lots of a big citation count. So they would only count the citations to journals where the count would be sort of well visible. Right? And this is exactly the impact factor. It's now called, they called it the impact factor back then, but it's really a redefinition of a bug into a feature. Right? They couldn't completely cover the literature, so they said, well, we only cover the best journals. And but this was just done because it would have been too expensive otherwise. Right? So that is the beginning of the impact factor. And well, so how does a journal get a high impact factor? So, for example, for one of the journals with a really high impact factor, is like 40 or so, is Nature. Nature is a journal that that has original articles out of all branches of the natural sciences. Right? And so it gets cited at least as often. So the dominant amount of citations that go to Nature are from the biologists who have, in their citation habits, are especially generous with citations. Right? They cite more than even physicists. And so even if it's according to this philosophy, this would be a good journal, and actually people are trying everything to get into these good journals. Also physicists will, because this is considered such a great journal, such a high impact factor. But the impact factor would be high even if none of the physics papers in Nature were ever read or cited. It has nothing to do with the physics papers there. And it's also a piece of fiction that the physicists would normally read the papers from the other sciences, or the biologists, or whoever, right? You only look at the section of it that concerns you. So it's a bit of a crazy idea to make a journal with original articles from all of science, because this will not, it's always a large part of the journal that will not be interesting for many of the readers, right? Anyway, it sells well, so as such it's successful, but it's especially successful because of this impact factor gymnastics, right? So, and this happens also for other journals, and actually the impact factor is very important as a marketing tool for the publishers. So the Nature Publishing Group they've fused with Springer. So there are huge companies that run these scientific journals, and for them, the typical way they market their journals is that they make package deals. So they go to a university library and say, well, if you buy all our stuff, you don't pay much more than if you only get the high impact ones. And you couldn't possibly do without the high impact ones. So this is why, as an argument of this sort, the impact factor is actually used. So it's a marketing thing. And if you look at the price list, if you're really crazy enough to try to buy one of these journals individually, then your price list, let's say, I checked the Elsevier price list, is directly correlated with the impact factor. They give you a list of journals with an impact factor and the prices, and it's just, that simply matches, right? Okay, so at this point, I think I should say a little bit about the publishers and what the business models are in this whole field are, because this is, as I said, this is one of the driving factors for this bibliometry. So you would think that you cannot make money by publishing scientific papers, right? The audience is small, right? Compared to any piece of the yellow press, the audience are ridiculously small. So there's a small readership. There's an extremely high demand on the quality of the content, and it's really not clear how you could make money on that. Right? So, but this is completely wrong, actually. So the person who invented scientific publishing for profit, in some sense, is Robert Maxwell. He was a Springer employee who got control of a small part of Springer in Great Britain, and he came up with this idea how to make this profitable. And the idea is that, well, the scientists who provide this content, they're working for free, right? And university libraries will just buy this stuff, right? So you have a guaranteed customers, and they will almost pay any price, because a university that doesn't have the main journals of a field cannot do science, right? So this is really a necessary ingredient of doing your own research. You have to read the other papers, right? So so you basically get the content for free, or you could say, well, as a publisher, you get it for free. You could say the content is paid for by the taxpayer, by funding the universities, right? And then you do your bit of printing work, and you'll sell that for a really high price back to the taxpayer, to the university libraries, right? So that is actually the model. So I said high price. So typically, I don't know what Turku's university library budget is and how much they pay for journals, but I guess large universities, it's easily in the millions, right? If you buy an individual subscription to a scientific journal, you should look to something like 20,000 euros a year. So this is not cheap at all, right? And very few individuals ever buy that. Sometimes there would be cheap subscriptions handed out to members of some society or so, but on the whole, these prices are really high, right? So, and if secured in this kind of package deal, the universities, I mean, are practically held hostage to this system. So there is so now the reported profits of these companies, profit ratio to turnover, is something like 30% or 40% or so. The numbers vary, the different estimates. Of course, they don't tell you exactly how much it actually costs to produce these things. But if you look at the price per article that they sometimes claiming it costs, this is completely ridiculous. It's impossible to spend that much money on a single article, right? They don't do the typesetting nowadays is done by the authors mostly, at least in the natural sciences. So we all use this tech system producing practically perfect articles that they could just take from there. It's little bit different in other branches of science where there has to be more editing actually. But for physics and mathematics, there's practically no editing. The typesetting is all done by the authors. The editorial boards are typically academic editorial boards. So these are also people who work for nothing from the publisher point of view. And then they just get these huge profits. It's on the verge of having to be called immoral. 30% out of turnover as pure profit, you might achieve that with drug trafficking maybe, but otherwise it's pretty hard to do that in any other field, right? So this gives extremely high profits, and these numbers are not small, right? So every university pays really large sums for that. So there is a bit of a counter movement to that. I won't go into that. Maybe we can discuss that later, called the open source movement. And there, this started when a few of the, of the American publishers, also Elsevier it's not an American company, but were also active in that. They were lobbying for a new, it was called the Research Works Act, and they wanted to secure this business model, especially in the States by appropriate laws, and that totally backfired. So there had been talk from the National Institute of Health. They fund the medical research in the States. There had been some talk that, with a slogan that publicly funded research should be publicly available, freely available. And so they tried to fight that, and this backfired. So now every funding agency in the world almost is working by that slogan. So so in the end, everything will be freely available, not behind paywalls as the publisher would like to have it, or these mega publishers would like to have it. But it's also, there's a huge number of new journals that work only electronically and are always free for the reader. This is called open access. Right? One problem with this, but this is really beside my topic here, but anyway, we might discuss that later. One problem with this is the quality control, that there are very many journals that are absolutely horrifically bad. So the new system is really not visible quite yet. Okay, so much for the business models. Let me, so my next topic here on my notes is, so one can make this citation statistics, and it's if you do this as a game, it might be maybe mildly interesting, but I think it's bad actually. It has a bad influence. And one way to see this is, so in economics there's a rule called Goodhart's law that says if a metric is used as becomes a target, it ceases to be a good metric. So if there's a certain number that you use to judge the performance of a company, let's say, and this is generally known, then the company can actively try to work towards that number. Right? So they try to improve only that number. And immediately it starts to be a bad measure because it measures something else. Right? So simply because the people who are being judged by that adapt, or if I might add to Goodhart's law, Werner's lemma, it is that if scientists believe that they're being judged according to idiotic criteria, they go out of their way to behave like idiots. And so one has to look at the kind of, if a young scientist knows that citation statistics is sort of the basis for many decisions, or let's say of hiring committees and of grant agencies, then you will work towards improving your citation statistics. There are many ways of doing that. Citing more is one of them. So the whole number of the citation numbers are continually rising, and you can't compare them between now and 10 years ago or so. So that's one easy way, and then you could have citation cartels. You cite your friends, and you make sure you don't cite your possible opponents or co-competitors. Right? So you begin to use the citation statistics, citations as a favor also. Right? So because you know this has a value in the market, we are sort of creating the currency by citing. But because that has a value, you begin to behave like it has a value. Right? You would definitely not try to write comprehensive papers. There should be only one thought per paper. it's much better for your statistics if you write more papers, more smaller papers. You try to go for the high impact journals because they will be the ones that promise you the most citations. Whether that actually happens is another question, but at least it's sort of a direction in which to go. So you begin to adapt to this system, and I think that is a very, very bad influence. Right? You're not writing good papers and try to develop a sense of what is a good paper. You know what is a good paper, namely what is highly cited, and then you do something that is highly cited. It also has a bad influence from the side of the journal. So if the top journals in a field are supposed to be the high impact journals, then everybody's trying to get in, and that has negative effects by itself. So for example, if you want to get into Nature, with something that some result that you've obtained, if you want to get a citation in a paper into Nature, the first thing you have to do is to simplify. You have to simplify the title. It should be something that almost seems to speak also to people from other branches. Right? So if I'm a theoretical physicist doesn't go into Nature anyway, because formulas will be abhorrent to most of the readers of Nature, and unfortunately that's what we have to use, right? So to say anything meaningful, so there are very few theory papers in Nature. But in any case, if you want to get in, maybe with an experimental paper, simplify the message. That's the first rule. You make a simplified title, and you also, well, you leave out all the ifs and buts. Right? Self-critical remarks are not warranted. Right? The referee might ask for that, and then you do it, but not before. Right? So it's a mode of power selling. Right? You only and you have to overstate your case. Right? By simplifying, you usually do overstate your case. Right? So I've seen papers, Nature papers, that were with titles where he said, well, okay, so this field of science is done, or what? Right? So let's say quantum computing, then a paper about universal quantum computing appearing in Nature, that seems to be the end of it almost, but it was actually, looking at it, it was just a small step in one direction. But the title was not a small step in the direction of quantum computing, it was quantum computing. Right? So this is very typical of Nature titles these days, and I think this is an extremely bad influence on science. It's not a bad journal actually, because many people try to send their best stuff there, right? So they have a lot to choose from. So it's there are many good articles in Nature, but this kind of pressure actually makes papers worse. Another example is the physical review letters. So that's also from the physics side of things. So the physical review is actually the collection of journals run by the American Physical Society. And they have one letter journal where only papers with up to 4 pages appear. Right? This was actually, there was just one physical review journal up until the 50s or so. I think that was the 50s. And then this had a letters to the editor section, like many ordinary journals have, right? So the letters to the editor. And it was more and more common to make quick announcements as a letter to the editor in the physical review, right? So it really just an announcement, right? So that people would be alerted that there's a real paper coming. And so they took these letters, and in the interest of getting them out faster, they made compromises about refereeing and about typesetting and so on. So if you look at physical review letters, PRL 1, I mean the first volume, first page, you have an editorial by Goudsmith that describes that, right? So what kind of compromises they had to do that. So it was all in the interest of speed, actually. And so now the impact factor of PRL is quite a bit higher than that of the other journals. And in some sense, this is natural from the citation behavior, right? So if you write a paper and you want to show to the referee and the world that you're up to the current literature, you would try to cite the stuff that the breaking news stuff, the stuff that you would find in PRL. So it's natural to give more citations to PRL than is actually warranted by the scientific quality of that paper. You're showing that you're up to standards, up to the current edge of science by citing the recent stuff, right? So the PRL had a relatively high impact factor from the start. And in this impact factor logic, that means it's the better journal. Or for some people, it immediately seems to mean that. So many people try to get their stuff into PRL because it counts more like that in that sense. And that means that you have to write short papers, right? So I call it the 4-page pest. You take content that would have a natural length. If you would write it up in such a way that people can actually understand what you're doing and maybe use it for themselves, it might need 6 or 8 pages, and then you compress until you're below 4. So I often have this situation that my students come and say, well, I have this PRL that seems to fit the problem that I want to solve. And I said, oh, but I don't really find the essential information here. And then you have to hunt for other sources. It used to be the custom that if you write a PRL, it's just an announcement. So there will be a full paper somewhere else. But with this impact logic, this stops happening. So because writing the long paper to go with a PRL gives you less prestige and more work, a lot more work to write the long paper, right? Maybe a paper with all the ifs and buts and all the little details that actually make the paper usable for somebody else. So increasingly, you have only the PRL. And that is very bad for science, right? The other side effect of having a single journal singled out by impact factor as the best journal in the field is that everybody sends their stuff there, as I said, right? So they have a lot of papers to referee. They get hundreds of papers every day. This is a flood that is very difficult to manage in a reasonable way. So what they do is they basically send the stuff to random referees. The slogan is that we want papers of broad interest here, and this can be tested by a typical member of the community. So it basically gets sent to, well, more or less randomly. It depends. The editors in the editorial office of PRL, I'm sure they try to do a good job here, but there's a large random element in there. So actually some people call this journal PRL the Physical Review Lottery. And every now and then they say, well, we are now increasing our standards further, which just basically means that they're changing the odds in the lottery. They're rejecting more. But that doesn't mean that it's less of a lottery, right? So there's a huge random component in the kind of reports that you get. Of course, as an author, you see the reports of the referees, anonymous, but you see the reports. And you get a lot of trash reports where somebody writes just 2 lines with a rejection, doesn't meet the high standards of PRL or something like that, from which you can't even tell whether they've looked at the paper. So you get a lot of those, right? Normally, an editor just should put that kind of report in the bin. But then it's the attention of referees is actually the most precious commodity in this whole business. to find actually somebody who knows something about this stuff and looks seriously at a paper is not so easy. Finding referees is notoriously hard for all journals, right? Also for PRL. So they just have to take these reports. And then there's, well, some people go to an appeal process every time. But the whole thing would be much less random in smaller journals. So I would like to contrast that with journals that have a particular topic. Let's say the Journal of Statistical Physics has been run by Joel Lebowitz for about 30 years or so. Has a clear profile. And if I see a paper in that journal, I can I pretty much rely that it's a fairly good quality, because the referees for that journal are specialists on that, right? And it's known that they do a careful job. So, and the editorial board tries to make a careful job here. When I see a paper in PRL, it doesn't mean anything about the quality of the paper, to me at least. I mean, this is my experience simply, right? So in that sense, it's not a good journal. Still, for some people in the community, this counts as the top thing. And I think this is very unfortunate, that basically a lottery gets to decide what is good scientific quality. So many papers are just written to go, sort of with the intention of getting past the referees, and after that you don't ask. Nobody is going to really read it. Maybe it will be cited a lot, but to be read and used for somebody else's research is not the rule for a PRL. Okay, so I think I have one more point here, which is what to do. Right? Now, that's not so easy. Right? So this is a huge system, and to change something like that is not easy at all. But it may help to understand that this whole system is not so old, right? So the invention of high impact and profitable journals by Maxwell was after the Second World War, right? Like 50s or so, early 50s. That's when it started, and it really became really profitable. There was a huge concentration process. There are basically only 3 big companies now, like Springer Nature is one, Wiley, and Elsevier, of course. Yeah. So there are these huge companies, but this style of scientific publishing is actually relatively recent. This whole impact madness is also relatively recent, and so this is, one has to think about that, and that things can be changed there. One thing that is very easily done this is for the scientists, is when you cite so the physics is in some way in a very good position because of a very successful operation called the archive, or it used to be called a preprint server. And this is a brilliant thing to have. Mathematics also is using it increasingly. Everything that I produce in the way of scientific papers goes simultaneously to the archive and to a journal. On the archive, everybody can read it for free. So one thing that is completely gone in physics is this question: will I ever get this published, or will I ever get this to my colleagues? The colleagues are going to get it anyway. Right? So the role of the big journals is no longer publishing. That's what the archive does. So publishing in the sense of making it available for free, instantaneously, worldwide. Right? That's something that no publishing company in the traditional sense can do, and the archive does that. Right? It's also not, the archive is, of course, has to be run. It's not for free, but various sponsors that help with that, and also at least in Germany, funding agencies are willing to give some money to the archive as well, because they see that's an essential service. So what can be done here is to spread the news that this is a way to at least do the publishing part for almost free. biologists don't do that in the same degree. There are some other fields that have started archives like that, but it's I mean, as long as I've been working I mean, the archive is at least as old as quantum information theory, this particular field that I'm working in, and there it has been only beneficial, a perfect thing to have. And so one thing that we can do is when we cite a paper, don't cite primarily the journal version. Right? So the journals like to, if you cite a journal paper and say it's, and in the archive you find it here, they tend to cross out the archive citation as sort of irrelevant, because to them publication is publication in a journal. Wrong. Right? This is the place where it's available for everybody. The other one is the place where it's only available behind a paywall. Right? So if you happen to work from home and you don't have a VPN tunnel open, then you'll see very quickly that what kind of money the publishing houses charge for individual articles that you're trying to read. This is really like 30 euros per article or something like that. So that can be a lot of money. And if you know the archive numbers, you just go to the archive. What else can we do? Well, changing I mean, the costs are completely overstated by the publishers. So one can actually run a journal for a much lower cost. And one way to do that is to let this archive do the whole handling of manuscripts. This is called an archive overlay journal. I was involved in the foundation of one of them called Quantum, the journal. And this is an operation that is going pretty well. So there we are taking it sort of out of the hands of the commercial publishers, and also try to find new ways of refereeing or judging qualities that are independent of all this bibliometry. A scientist who reads a paper can really see whether it's a good paper by looking at questions like, what is the basic question? Do I know more after I read this than I knew before, and stuff like that. So a good paper can be recognized, and you really don't need the citation counts for that. So overlay journals is another thing. Let me see, what else can you do? Well, not too much actually. Yes, one thing I wanted to mention is, I said maybe pretty much at the beginning that all scientific results are spread around in the form of articles, of scientific papers. But in this day and age, this is not necessarily so. So the smallest creditable unit could be something else. And there are interesting projects around where scientific collaboration doesn't go via papers. So for example, there is the Polymath project, where problems are solved in a massive collaboration of whoever wants to join. And this has been quite successful, partly because one of the really brilliant mathematicians of this time is very active in it. That's Terry Tao. But also but this is a really serious enterprise, and it's, I think, looking at such examples is very helpful to maybe come up with the new system that is adapted to the world of the World Wide Web, and is a reasonable scientific communication platform. The current journal system definitely isn't, and the bibliometry, the counting of citations as a fake way of assessing quality plays a very infamous role in that. And with that, I thank you for your attention.
Thank you very much. So now we are ready for questions. I think this is on. Okay, I have to start with one question, and although I have two, but I will start with one, and the other one will come later. There are more and more PhD students, more and more postdocs. Having a position nowadays is incredibly more difficult than it was when I was looking for a position, and which was perhaps more difficult at the time when you were looking for a position. And at the same time, we do know that these are the criteria for hiring from the university, and there is nothing to say. This is a fact. I mean, everywhere, criteria for hiring, but even criteria for having postdocs, and even criteria for having a grant, which allows, of course, to continue doing research, are based on this matrix, are based on these indicators, which many of us think are just crazy, and we all criticize them. However, at the same time, we do know that in 95% of the time, the people who eventually get hired are people who are good, surely, but also they have high impact factor, and they have success in funding, which comes with high impact factor, and so on and so forth. So in some sense, if I have young students, okay, of course I want that they are aware of the fact that the system is broken, because it is broken. But how can I really tell them, forget about it, this is not the thing you have to do? Because I know that that's the only, for 95% of the cases, this will be their only chance, actually, to continue in academia. Of course there are exceptions, but they are exceptions.
Yeah, of course you're right. There's too much, in actual fact, depends on these metrics. So the appeal partly goes to the old guys like me, right? Who in some sense, well, on every committee that I'm on, you can be sure that nobody will list the H indices, right? Yeah. You can make your influence go in that direction, certainly. So whoever is in a position to make decisions in academia should be more aware of that. And this is maybe in this crowd here, they're not the majority academic decision makers, but we have to spread this knowledge that that it is really counterproductive. It's not just a bad habit, it's not something, an accident, it's not something that will sort of average out, but it is actually pushing science in a bad direction. And I think the realization is increasing, and there's some good signs, so also some bad signs. Like I think in Italy, for some, they have these nationwide competitions. And for some position types, there's a minimal H index required. This is a disaster, right? I mean, for example, the German Science Foundation, if you write a proposal, nobody asks for these bibliometry data. They say, tell us what are the 5 most relevant papers for this project that you've written. Okay, and then a referee has a chance to actually look at them. Actually looking at papers, in the final rounds, you have to do that. I mean, even so, there's still the danger that in the early rounds of a hiring process, if you maybe have 200 applicants, then the citation data will be somewhere there. But on the other hand, most of the applicants that are clearly not in the top bracket, you identify very quickly without that. I mean, half of them or more will be essentially in the wrong field, or and stuff like that. I mean, so the course filter, initial filter, in my experience, does not really require bibliometry so much. And in the final rounds, you would be making really bad mistakes. So we know these colleagues who are running paper mills, right? So you keep writing about the same stuff, essentially. You can basically copy your introduction from one paper to the next, and it's all the same thing, right? And maybe highly cited, but still trash. We have this colleague in our community. I'll tell you later who it is. Who was boasting when we were talking at a conference that he could take any idea and turn it into a PRL. So when I was back home, I checked and found it was true. It was actually, yes, like turning any idea into a PRL. So bad.
And I think it's very important, actually, that we say this, and that you say this as a very established figure in the field. I hope that somehow this will lead slowly to a change, at least in the new and future generations somehow. And definitely, I agree with you that there are very good signs. Quantum is a nice example of young people trying
this is run by young
to
people,
to do this. Yes.
And it is already Quantum, this overlay journal that was started last year. I think they have the first birthday sometime around this time. Already has a good reputation. Yeah. It's you would agree, right? Mm-hmm. One thing. I mean, of course, you have to teach young students how to write a PRL, and you have to get a little bit cynical while you do that. But on the other hand, you should also make clear what good scientific work is, and this is much more important, right? So really tell what makes a good paper, and then that's a separate issue. How do you write this up for PRL? It only makes sense to actually do that if you have content that for which you need a wide circulation for some reason, right? Or not every content is really good for that. So you have to. But in some cases, if you have something that you really want to tell to the whole community, and it can be said briefly, by all means try that. But it's. You have to also teach how to make such decisions.
I agree,
Trying to get everything into PRL will
I agree. It's a very bad example.
Increase the paper mountain with no gain.
I agree. Okay, questions? Yes, use the microphone just for the...
Actually, I have a loud voice.
I also have a microphone for the recording.
Okay, very good. Thank you very much for interesting and important talk. I would like to mention one more thing which you actually touched in your talk already, maybe with two examples. In my opinion, the scientific citation databases don't cover everything that we should consider interesting or important.
Yes, yes.
As for theoretical computer science, the publishing in journals has not been an issue for very, very long time. Mm-hmm. I can find important groundbreaking papers on theoretical computer science already from 1990s, which never existed in journals. They publish in conferences. Yes. They have referee practice in conferences, unlike in mathematics in most conferences. Yes. And the papers are published first in conferences, maybe then later a journal version will come, if it will. Yeah. In many cases it doesn't.
Yeah.
And my second example comes from Russia. 2 years ago, I was in St. Petersburg in polynomial algebra conference, computer polynomial algebra. And there was a Russian Academy member, Sergei Slavyanov, also attending to the conference, and he has greetings from the Russian Ministry of Science and Education. It was read, unfortunately, in Russian, but a local doctoral student kindly provided me a translation of the main points. And one of the main points was that the Russian Minister of Science was highly dissatisfied with the fact that in Helsinki University, the professors publish 10 times more in average than in St. Petersburg. I hope the translation was correct. But I guess that this is not an indication that the professors in Helsinki University are 10 times more laborers than those professors in St. Petersburg.
Or better.
Or better,
yes.
I guess this is an indication that professors in St. Petersburg publish in those journals that are not covered by those international databases. I think so.
Yes. Okay. So actually, ISI specifically does not take non-English language journals at all, right? And well, one has to admit that most of the publication business now is in English, so it's not as bad as that would have been like 50 years ago, but that is definitely a filter. The academy, the Russian academy, though, has recently revamped their funding practices and put much more bibliometry in. Unfortunately, actually, yeah.
Okay, so new questions, yes.
Hello, my name is Andrew Labille. I'm not a scientist, I'm a computer programmer, so you'll have to excuse my non-sciencey kind of question. the method that you describe of counting citations seems to be very simple. It's
Yes.
basically a
Yes.
single
Yes.
parameter with a value, right?
Yes.
So, and you also talked about how you could actually test, you could actually judge the results of your bibliometry by using, for example, judgments on existing papers or scientists. So my question to you is, could you, by using perhaps more parameters and populating the parameter space a little better, or by using a slightly more sophisticated method of counting the citations, for example, citations from scientists who have high citation counts count for more, basically find an optimizer that could actually approach what is considered to be the correct solution?
So, yes. I think this is actually a bad approach to the problem. Trying to improve bibliometry. I mean, there are journals about bibliometry. This pseudoscience is actually also carried on in peer-reviewed journals. The bibliometers are reviewing each other, right? And very often, I mean, we just heard this example from computer science. Different disciplines have very different publication cultures. Indeed, in computer science, it's very clear that the main thing are the big conferences. For a physicist, when I tell a colleague this is in a proceedings volume, then he assumes, or some of my colleagues would assume, that this is a piece of trash that I just sort of recycled for a proceedings volume. And this would be totally wrong assumption for computer science. So if quantum information is sort of on the fence between the two, so I know this other culture very well. In the humanities, it's books very often, right? And journal articles are completely secondary. So, okay, so improving the bibliometry. Probably the bibliometers, those who would call themselves bibliometers, would call this finding better predictors of, but of what actually? So I think basically any method of counting that is content-free is intrinsically evil. So this is the real problem, right? So you're getting a method that an administrator can administer, and they don't have to look at the content of what was actually done. And if you try to judge science and leave out the content, this is like judging literature by word counts, or maybe, if you wish, by defining popularity in terms of Facebook friends. Right? This is the sort of mentality that goes into this, and this is the real problem. Of course, you could, for example, there have been various corrected versions, right? So an H-index, a version of the H-index that was normalized to the particular field, and that they actually called hireability. Higher, as in to hire, right? So employ something like that, and it was. They thought if you just take out this one bias, I mean the bias of subfields, then it is a much better indicator. Well, it's not, because the same problem happens within each field, and it's totally unjust to people that are working interdisciplinarily. Right? So all these improvements that have been, or for example for the H-index, there is a version where you don't count your own citations, or where you divide by the number of authors. All these things take out some obvious bias, but they produce another one somewhere else. So in some sense, I would prefer the plain and simple H-index, because everybody can see that it's utterly idiotic, and you could see this better. If you have like 7 fudge factors built on top of it, the thing isn't actually going to be better in any sense. It doesn't begin to measure scientific quality, but it's just a more complicated measure that is more difficult to analyze. For the H-index, it's just plain stupid, right? You can see that. Everybody should be able to see that. But H-index with 7 corrections built on top of it, complicated formula, something else. I mean, you could probably build statistical indicators of future success for young scientists, so stuff like that. Right? This is what bibliometers would probably want to do. Right? But then again, if a measure becomes a target, it ceases to be a good measure. So people will immediately start gaming the system if this becomes like a universal practice. So I think it's much better to make the appeal to say, if you want to know something about scientific quality, you have to read the papers. There's no other way than looking at what is actually done.
Yeah, but I have I would agree, but there is one issue here. I think that is the fact that actually the number of papers are increasing so much,
Yes.
and our time for reading paper is also less and less.
Absolutely.
Because we have to deal with many other things, and also on top of that, each field is becoming more and more specialized. So you need a lot of expertise often to really understand the content of a paper. So the people who should read these papers to understand the content and evaluate the person are experts from a very small range, and they, I assume that they would be in a stage, say they are in a committee. It seems to me very complicated actually to effectively have a process of this type for things like hiring people or even evaluating grant proposals. I mean, nowadays we have these grant proposals with, I don't know, I'm evaluating one of these 208 pages, and I have to evaluate it in 2 weeks.
Yes.
And I mean, and it's a whole bunch of different experimental and theoretical results.
I
and
know.
I mean,
Yeah, sure.
so it's hard. It would
Yeah,
be,
yeah.
from some points of view, it would be nice somehow to have some help. I completely agree with you, but at the same time, I see some difficulties that I also live in daily, actually, with.
One problem, that attention of referees is really the thing that is scarce, right?
Yeah.
And that one thing to point out in this connection is that in the current journal system, a lot of this is just wasted. So what the referee does is help the editor saying yes or no, or maybe sometimes suggesting particular improvements. That's a more positive role. But on the whole, none of this, what the referee learned about the paper, will be made useful for the readership. So finding other ways of refereeing that allow more of this work that the referee does to actually see the light. I think that would be helpful. It would also be better for better reports, and it should be seen as a part. I mean, it's part of the essence of science that we criticize each other, and if the papers are not read, it doesn't happen. And so I think it's organizing that process in another way, and not just so. If you hand a journal to a paper to a journal, they consider that manuscript their property somehow, right? And then they do something with it. But it really is a contribution for the whole scientific enterprise, and it should be treated better than as a way for the Nature Springer Group to make more money. And it's some possibilities, of course. I mean, you could have public comments and stuff like that. But then we know how things can go wrong, right? Actually having public votes on the quality of papers is something that has to be done with extreme care, because it can very easily backfire to become. You know, people will start to write bots and so on. So you have to, I don't know, you don't really want to go into authentication for that and all these things. But to have more feedback from people who use the paper, that would be brilliant. And ways to organize that would be nice. For a journal, once it's on the shelf, there's no possible way to add to that. And we should use the modern possibilities, electronic possibilities, to have more added to a paper, that a paper can develop a history, and that will be telling about its quality. But the publishers don't help at all. For them, it's once published, it's correct forever. But what do we do with mistakes that we find in papers? That's another thing, right? There should be an active correction process. So a scientific information system that is adequate to the possibilities that we actually have would definitely have to include that.
Okay, so more questions.
So the first question is, as you have kind of thought a lot about all these different aspects, have you written about this in any way? That's a short question.
Not,
and then,
yeah, okay.
Yeah, and the second one is, so you mentioned this journal where you are involved, Quantum.
Yes.
So how are the costs of that journal to maintain this compared
Yes.
to the
Right. So, first of all, I have written. I was actually invited to write an opinion piece for Nature, and so at a similar at a conference I talked about that. Actually, the journals there were some representatives of the big journals, and they staged an evening explaining how to get in. This was a conference in China, so then there was a lot. I used a part of my talk to make some remarks of the kind I made now, right? And there was a lot of discussion, and so I got invited to write an opinion piece for Nature that appeared a bit over 2 years ago, right? It's not a regular article, right? And I've written blog entries. I've talked in various places about this, so it has been an interest of mine for quite a while.
We can post this link in the Facebook. Oh, you tweeted already, so you can read it. It's interesting because it was somehow against
Yes.
a comment against Nature in Nature. It's nice.
Yes. Yeah, well, but it's still true that, so actually in the debates there, right, so there was this evening where the journals were presenting themselves, and so the young scientist gets up and says, "Who are you anyway?" to a young editor from Nature. "Who are you anyway that you decide about my career?" Right? And young woman, but very professional, and I think perfectly good answer, saying, "Well, we don't do this. We don't pass any judgment on your careers. We select papers in a way that we think our readers want it. And if somebody makes a judgment about scientific quality out of that and hires you because of it or doesn't, ask these people." Right? So the disease is sort of with the decision makers in the scientific community and not necessarily at the editorial board. I think that's a bit too easy, but anyway, I think that was a good answer actually. Okay, quantum, the costs of quantum. There's now an article charge that I'm not quite sure about. It's I think 200 euros.
Yeah, it's in the level of 150 or 200,
Something
which
like
should
that.
be compared
So
with the.
it runs, and so there's some sponsorship here, but most comes actually from this. And for the initial project was sponsored, but then there are these article charges which are enough to run the software. This is a fairly complex editorial software. For example, when I submit a paper to the journal, it must be clear that I'm completely out of the evaluation process, and these pathways have to be organized reliably and in a good way, right? So this is what the software does. That costs some money. This was taken from a commercial provider, and now the journal is hiring 2 managing editors. So up to that, it was all volunteers, but now there will be 2 professionals on the team. So of course, I've also been talking to representatives of Springer and so people who do the journals on the other side, and so one opinion I heard there was just wait until the quantum becomes large, and then they will die of their own success. Because, this is actually the way that some such projects have taken. It is actually, I mean, the kind of job that PRL does with hundreds of submissions per day is, well, this has to be organized in another way than something handling maybe this many papers per year. Right? And, but so far, I think they're holding out. It's working. And the costs are in that range. Usually, they can be charged to a grant. They can also be waived in some situations. So I think it's that, but this is close to the realistic cost. I mean, what the journals claim, the commercial journals claim as prices is at least a factor 2 too high, probably a factor 5.
Yes, and in any case, to publish in other journals, open access journals, costs I don't know, 2,000 euros per article. So it's really nothing compared to what you would pay in the many of the other journals. Questions? Yes.
First of all, thank you very much for a very interesting presentation and discussion afterwards. I just have a comment regarding the third point, what should we do? And I apologize if this is a very naive comment, but I thought that, of course, it's all about the culture, like what do we appreciate, how do we evaluate things? And of course, culture begins from us. And this is what I talk from my own experience, being part of a research group and scientific group. It's all about us, like, for example, if we say, like, I published a paper or I submit a paper, then the problem is everybody asks, where did you publish? And who asks you, what did you publish? And I think it begins from us, that we are interested in the what, not where, and like how much. And I think that's maybe one thing that we can all do, is like kind of generate more among ourselves this interest in what are you actually doing, what do you have to say, rather than where did you publish, what is the number, all these more external factors. That was just my comment.
Very good. I totally agree. Yeah. Thanks.
Of course, it's also true that we are very often biased in many ways. I mean, not just referring to where it is published, but who has published. I mean, it happens objectively to many of us. If I receive a paper to referee, of course I try to be objective. But if I look at the authors, I do have a bias. I mean, there is not. I try to, be as objective as possible and look at the contents. But I have to admit it. It is a fact, and this is also related, maybe also related, and we can try to fight it, obviously, or to be more aware of.
But it has always been like that people build a reputation, right?
Yeah.
And if you, of course, you see who the author is. And your feeling of how you approach a paper depends on what you know, what you expect, and it has to.
Yeah, but it's also true that sometimes people who have a reputation write papers which are bad.
Yes, that's true. That's true. Yeah,
and sometimes it's difficult
absolutely.
to Okay. Let's see. More questions or comments or proposals of other ways? Yes.
No, just a comment or to hear your opinion, because, very interesting, your talk. I'm living here and doing research in Finland, but I'm from Argentina, so I always also have this talk with colleagues about how difficult it is from our countries sometimes to publish, because what you were saying just now, the prices of open access, for example, and imagine 2,000 or 3,000 euros for our countries is crazy. Of course, there are like waivers and stuff, but it also affects, there are different qualities in research as everywhere, and maybe compared with Europe, maybe it's not, we have groups that don't do research at good level, but it's also another problem to be able to publish your results or to grow when you don't have the means to publish in important magazines.
So I think that you're not. What is your field? I didn't quite catch that.
Microbiology.
Microbiology. So you should be lobbying for an archive, because this is. I mean, web access is not the problem in Argentina, I would say.
No.
And so if you want to spread what you do, just to make it available to your colleagues, and so they can start forming an opinion, I think that's a very good medium. The question of what journal it appears in finally is in some sense secondary. Actually, in our field, my feeling for how somebody builds a reputation, it's largely via the archive. So if I see archive papers from people, we have a weekly archive scan in our group, and if a name comes up with stuff that is interesting to us and comes up repeatedly, this is really the beginning of a reputation. I don't care at all if that stuff appears in PRL or not. I actually don't look at PRL, or only second. That's only secondary. My first and main literature scan is the archive. So it would be great if other fields had a similar culture, because it actually solves this problem of getting your stuff to the world in the first place. Right? So there was a time when publishers were sort of completely in control of this, where many people were sort of disgruntled because they could never get their stuff published, and there was maybe a bias against that in the community, and the referees would never like it and stuff like that. This is all gone. This is all gone. You just put it on the archive. If it's not extreme, well, if it's not in some sense obviously unsuitable, they will take it, and it costs nothing. So this is I think this is a very important part of the scientific communication, and it's strange to hear. I mean, as I said, I've been talking in various places about this, and also with a mixed audience from different scientific fields, and it's strange to see that this simple idea wasn't pursued in other fields. I would really definitely recommend that.
Yeah, and I think that really in physics, really I believe everyone, first things they do in the morning, students, postdocs, everyone looks at the archive first. So also because it is, you see the papers there before they are published. So it's you can see it immediately. There is no delay. So it is really universal to look at to learn about results by looking at the archive in the morning. And I think it's a very good thing, of course. Yeah. Yes.
There was a vote recently about how the archive should develop, and some people were asking, shouldn't we do the refereeing as well? And there was a vote against it, which I think is very good, because this one function the archive does perfectly. Right? This is immediate, worldwide, free distribution. Right? This is fantastic, and to burden that with additional functions and is maybe not a good idea. You can do such things as overlay, right? So overlay journals, or there are secondary sites where one's called Cirate, where people list the papers they read, and then if a paper gets read by many people, you can get some count there. But also it's really a commenting function. That can be added by other people, but the core functionality of the archive has become essential for us. Yeah.
Okay, let's see if there is one final question. Yes.
So I think if this is the last question, and since the number of publications will be growing all the time and archives will be growing, do you think if there will be some kind of machine learning like Google's Watson or whatever it is to not review them, yes, but do a bit refereeing? Or
yes. Good point. Good point. I think this is inevitable to some extent. We need better way to control the paper mountain, as it's called, right? So this is we are writing too much, right? There was a time when a PhD student was supposed to do a PhD thesis. That was the only thing he would write in those years, right? And now the typical thing is that they write like 5, 6 papers. Right? This just adds to the mountain. And yes, we are writing too much for reasons that is described to some extent, and we need ways to filter, and better filters are definitely needed. Whether this takes the form of some kind of machine learning, that's another question, right? But we need ways to intelligently deal with this flood of information. Definitely agreed. How this should be organized, how this can be done in an unbiased way, whether this should be connected with a quality judgment or hiring decisions is a totally different story. Many things to think about, but something has to happen there. Yeah.
Okay, very well. As you know, at the end of the Science Cafe, we always have, in this case, about 15-20 minutes of time that you can use to ask questions to Professor Werner individually if you didn't want to ask a question here in public. So just, he will be around until 7, so just come here and have a chat with him freely.
It will be a pleasure.
And I would like to thank once more Professor Werner for this interesting, super interesting Science Cafe, and all of you for being here and for the interesting discussions.
Thank you.
Thank you. Thank you very much. It was really nice and interesting, and now I can